In this video, we're going to be looking at solving 4 algebraic equations. Now, it's a big mix. So each equation that we come across, we're going to discuss how we know what we're supposed to do. How are we supposed to solve this? Now, since there are 4 problems in this video, may be kind of long, check down in the description for some timestamps so you can jump ahead to whatever problem you want to look at. So let's start with this one right here. We want to solve 4x squared plus 5x plus 3 equals 0. Now, there's nothing crazy going on here. This is just a nice looking quadratic equation. So if it's a quadratic equation, let's go through our progression. The first thing we try to do is to see if we can use the square root property. But that's not going to work because we have 2 instances of the variable x. Okay. So the square root property, you really only want to have 1 instance of the x. You want that to either be the square or be contained inside of parentheses squared. So no square root property. We could then try to factor. That's the next thing we'll try to do. If I try to factor, let's see if that's going to work out. So we try doing the AC method. So 4 times 3 is 12. Okay. Are there factors of 12 that add to 5? And the answer is no. So that means this guy is not going to factor at all. And then we try to do completing the square. Now with completing the square, you want the lead coefficient to be 1, or at least a way that you can get it to be 1. And you want the middle coefficient to be even. Well, since this is 4, one of the first steps I'd have to do is divide everything by 4. And when I do that, I end up creating fractions. So if in the process of completing the square you end up with fractions, that's usually not the best thing for you to do. So that leads us to the method of last resort. Not first, but last resort. When nothing else works nicely, quadratic formula. So the quadratic formula needs to have everything on the same side of the equation, 0 on the other. And the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Every time you need to use that formula, write the formula. And let's see, make sure we identify things correctly. So here in our problem, a is 4, b is 5, and c is 3. Make sure you pay attention to your signs. Alright, so x is equal to, big fraction, negative b, so that's negative 5, plus or minus the square root. So b is 5, so 5 squared is going to give me 25. And then minus 4ac. So what I like to do is I take all of the minus 4ac and write that off to the side. So it's negative 4 times a, which is positive 4, times c, which is 3. Alright, so you can either do this as, you can do 4 times 4, so that's 16 times 3. But what's probably more familiar to you is to do 4 times 3 to get 12, and then 12 times 4 to get 48. Don't forget about your signs. This all together gives me a negative 48. And that's where most people make mistakes, is they don't pay attention to the sign. They either don't bring this negative here, or they end up getting an extra negative somewhere. So that's why I circle it. Do what I do, and you won't have any problems. And this is all divided by 2a. So a is 4, 2a is 8. And then we'll just clean things up. So this is negative 5 plus or minus the square root. 25 minus 48 is negative 23. All divided by 8. The last thing that we need to do is to try to simplify this radical. Now 23 is prime, so we can't do anything else with that. However, you do have a negative factor on the inside. And having that negative on the inside means that when I simplify, I get to pull an I out in front. So it's going to be plus or minus I times the square root of 23. And this is all divided by 8. There's nothing else that I can do here to simplify. If this number here and what's in front of the radical and the denominator all have a common factor, you can reduce it by that. But nope, this is it. And you can see by the crazy answer that we have that this is not an answer that we could have gotten from factoring. You could have gotten this answer from completing the square, but it would have been a lot more work than using the quadratic formula. That's why we go through the progression like this to see if I can use one of these guys up here at the top, because if I can, it's usually going to be a lot less work for me in the end. All right, let's go to the next problem. For the next problem, you see that we have fractions. Okay, we have two fractions that are equal to each other, so this is called a proportion. And like with most equations that we come across with fractions, our primary objective is to get rid of the fractions so that we can then see what kind of equation we have left over. Now, in a proportion, the cross products are equal, so that means that the product between 4 and 7x plus 2 must equal the other cross product of 3 times 5x minus 9. So that's what we mean when we say the cross products are equal. It doesn't mean that they give you two separate equations. That means you go from this one equation to this one equation by setting the cross products equal to each other. And now we solve this. So the first thing we need to do is distribute. So we end up with 28x. 4 times 2 is 8. On the right side, distribute the 3. So we get 15x. 3 times 9 is 27. So we have no fractions now. We identify the type of equation that we have left over. This is linear. You just see x to the first power, so it's a nice guy for us. So we need to move all the variable terms to one side. So we're going to subtract 15x on both sides. Now, you don't have to do this all in one step, but you can. You can go ahead and move the 8 to the other side if you want. If you don't want to, and you just want to say, you know what, I need to take this one step at a time, that's fine. So then you have 13x plus 8 is equal to negative 27. And then you subtract 8 to move the constant to the right side. So 13x is equal to, combining these, that's negative 35. Divide both sides by just the coefficient. Don't divide by x. Just divide by that coefficient. So x is equal to negative 35 over 13. Now, again, you simplify as best you can. 35 and 13 don't have any common factors. So that's it. That's all we have to worry about doing for that one. Okay, so it started out as fractions, but then it became a nice linear equation for us to solve. All right, let's see what else we have. Oh, you're gonna love this one. All right, so we have x plus 4 is equal to the square root of 3x plus 52. So the first thing that should stand out to you is that you have a radical. So this is a radical equation, so we're not even thinking about, do I need to complete the square or the quadratic formula? None of that even matters right now. What matters is that we are able to get rid of the radical, get rid of the problem, and then see what the equation is after that. So when it comes to a radical, and you're trying to get rid of it, you have to get it by itself. It's by itself. And then you want to raise both sides of the equation to a power that matches the index. Now, with a square root, the index is understood to be a 2, so you raise both sides to the second power to undo the square root. Okay? So I'm raising both sides of the equation to the second power. The right side is really easy to take care of, but the left side might take a little bit of work. Here's what you need to remember. When you have a binomial that's being squared, this is a special product, and you end up with a squared plus 2 times the product of a and b plus b squared. So that's a special product that I learned a long time ago. You can always kind of be cheap and lazy on this and just take x plus 4 and do x plus 4 times x plus 4. But I want to use the special product. So I want to square this guy. So when I square x, I get x squared. The middle term means doing, like this is your a, and that's b. The middle term says do the product of a and b. So x times 4 is 4x. And then multiply that times 2. So 2 times 4x gives me 8x. And then b squared, so since b is 4, my last term here is 16. On the right side, you squared the square root. Those guys act as inverse operations of each other for the most part. And we have 3x plus 52. All right. So a couple of things to note here. I squared each side. I did not square each piece. I didn't square x and square 4. I had to square this as its own quantity of x plus 4. And you might say, how come you didn't square 3x and 52 over here? The square hits the radical first, and they kind of dissolve each other away, leaving us with just 3x plus 52. So now we don't have a radical. We have something that is quadratic, and how do I know that? Because I see x squared. So since this is x squared, it's quadratic, I need to get everything to the same side so that I can figure out what quadratic method I want to use. So I'm going to subtract 3x on both sides and subtract 52 to finish bringing everything here to the left. So these guys go away. Combining like terms, we have x squared plus 5x minus 36 is equal to 0. You still have the right side of the equation, so you can't ignore that. Don't leave it blank. X squared plus 5x minus 36 equals 0. This is a nice looking trinomial because the lead coefficient is 1. Can we find factors of 36 that subtract to 5? And the answer is yes. I can factor 36 using 9 and 4. Those are factors of 36 that have a difference of 5. And now we just have to get the right signs. So since the middle term is positive, the larger of these numbers will be positive. And in order to get a negative 36 at the end, you need to have the negative on the 4. All right, so this gives me x is equal to negative 9 by using the zero factor theorem. Or from here, x equals 4. All right. Now, a lot of students just want to box these answers and move on, but you've got to check your work. Okay, so let's check x equals negative 9. I'm going to do that off here to the side. So check x equals negative 9. Always go back to the original. So if I plug in negative 9 for x plus 4, does this equal the square root of 3 times negative 9 plus 52? Let's see, negative 9 plus 4 is negative 5. Does that equal, let's look at this. This gives me negative 27 plus 52. Does that equal the square root of 25? And the answer is no, because that square root symbol that we use means the positive or the principal square root. So we end up with a statement that's not true. So it means this guy right here he's extraneous. We didn't do anything wrong. See, the power property says that all of the solutions of the original equation can be found among these guys. It doesn't say that all of these solutions work. It just says if there's a solution here, it has to be down here somewhere. Now, there are times when both of these answers work. There are times when none of them work. So we still need to keep going, and we need to check x equals 4. All right, so checking x equals positive 4. If I plug in 4 here for x, does that equal the square root of, let's see, it's 3 times 4 plus 52. So 4 plus 4 is 8. this is 12 plus 52. So does 8 equal the square root of 64? And yeah, it does. So negative 9 doesn't work. But when we plug in x equals 4 into the original equation, we see that it does give us something that is true. All right, now keep in mind that if you were doing this in my math lab, you would only type in x equals 4 because x equals negative 9, again, is not a solution to the original equation. All right, one more problem. 6x squared plus 12x equals 5x squared plus 10. You see that there are no fractions, there are no radicals. There's nothing really crazy that stands out in this problem. This is just a polynomial equation. So when it comes to a polynomial equation, the first thing you want to do is get everything on the same side of the equation. So that means I need to take these terms right here and move them to the left. All right. Now when I do that, that's going to come over as a negative 5x squared and a negative 10. You want to make sure that you arrange your terms in descending order, starting with the highest power, working your way down to the constant. So this is 6x to the third minus 5x squared plus 12x minus 10 is equal to 0. Now, if you think about the progression we use for the quadratic equation, it doesn't really apply here because we have something that's x to the third. Okay, and these guys don't all have a common factor, but we do have 4 terms. And what we know is that when we have 4 terms, we try to factor by grouping. So in the first group, we see that there's a common factor of x squared. When I factor that out, I have 6x minus 5. Now look at the second group. The second group that begins with a plus. The common factor for 12 and 10 is 2, so I'm going to factor out a positive 2. So if I factor or divide that out, I get 6x minus 5. And again, this is an equation, so we still have equals 0 on the other side. So these guys are exactly the same. So complete factoring by grouping by writing that in front times what they were connected to, x squared plus 2. All right, so we have this polynomial completely factored. And when you factor, this is where you want to use the zero factor theorem. So the zero factor theorem would then say that 6x minus 5 is equal to 0, or x squared plus 2 is equal to 0. All right, so do these one at a time. You've gone from something that is x to the third to 2 smaller, more manageable equations. So solving this one right here, we know that 6x is equal to 5 by adding 5 to the other side. Divide both sides by 6. So we get x is equal to 5 over 6. Now, one of the good things about these polynomial equations, is that your answers are going to work. Like, there's nothing that's going to say, oh, this guy can't work. When you have radicals and fractions, you've got to go back and check to make sure that everything does work out right. Here, you see that it's x squared. So if I get the x squared by itself, x squared is equal to negative 2. To get rid of the square, this is where you use that square root property. So you apply the square root on both sides, and remember that plus or minus. So x is equal to plus or minus. Now you can't do anything with the square root of 2, but you've got this negative right here. So the negative factor inside comes out as an I. And we like to write that in front of the radical so that the radical sign doesn't accidentally go over it. So here we go. Here are the other 2 solutions that we needed for this polynomial equation. Remember, the degree of the polynomial, 3, tells me that I should have 3 solutions. There's one. and the plus or minus gives me 2 more solutions. Now these guys are imaginary. It doesn't mean that they are not solutions, because you can take this and plug it back into the original equation and you're going to see that it works out. All of this means is that these guys are non-real. They are solutions, they're just imaginary.